and welcome to Chemical Formulas, Naming Ionic Compounds. I'm Mr. Collard. In this tutorial, we will name binary ionic compounds, naming ionic compounds with transition metals, practice with transition metals, naming ionic compounds with polyatomic ions, and practice with polyatomic ions. Let's look at naming binary ionic compounds. The first step is to write the name of the positive ion first. Typically, this is the metal, and metals typically are the less electronegative element in an ionic compound. The first name of the binary ionic compound is not modified, meaning the element name is used. Then you write the name of the negative ion second. Typically, this is a nonmetal, and usually the nonmetal is the more electronegative element in the ionic compound. The element name for the negative ion is modified to end in the suffix "ide." So for example, the formula is CaF2. This is an ionic compound. The name would be calcium fluoride. Fluorine's the element name. You drop the INE ending on the element name and modify by adding the suffix IDE. Or ide. Naming ionic compounds containing transition metals. Transition metals can have ions with more than one positive oxidation state. A Roman numeral is used to symbolize the specific positive oxidation state of a transition metal in the formula. The transition metal positive ions we deal with typically go up to a maximum of +7. So we need to know the first 7 Roman numerals, and they are for 1, 2, 3, 4, 5, 6, finally 7. Those are not on your reference table. You should be familiar with them. Let's look at ionic compounds containing a transition metal. We're going to determine the oxidation state for the positive metal and negative nonmetal ions, and then name the compound. We have to know the oxidation state of the transition metal in the compound in order to properly name it. So we look at FeCl2, and we know, using the picture method, whether you think it in your mind or you write it down, there's 1 iron plus something oxidation state and 2 Cl- ones. Therefore, the 1 iron plus ion has to be +2 to make the sum of the oxidation states in the compound add up to 0. We know we have an iron +2 and we have a Cl- 1 ion. And yes, there are 2 of them. We could add this coefficient of 2. It's a very good habit to get into for later units in the course. But right now, I'm primarily concerned with knowing that this iron is a +2 ion because the first name is iron Roman numeral 2 because of this oxidation state. Last name, chloride. More electronegative element, chlorine, change the suffix to ide. This is a binary ionic compound. Now at this point, I'd like you to stop the video, work through the next 3 examples with positive ion, negative ion, and then proper name. These are all binary ionic compounds, and come back and we'll check your work. Welcome back. Let's check your work. Now I'm not going to do the picture method for each one of these, but I'm going to be thinking about it in my approach. I know this is iron plus something, and I know, looking at the formula, I'm going to have 3 Cl- 1 ions, and the proper name of this ion is the chloride ion. Thus far I've been calling it a chlorine ion. Now I'm going to use the proper chloride ion. The 1 iron ion has to be +3. Therefore, this compound is iron Roman numeral 3 chloride. Let's look at the next example. This is a 1-to-1 ion ratio. The nickel is going to be positive something because it's a metal. There's 1 oxygen. Oxygen is almost always a -2 ion. Therefore, this 1 nickel has to be +2. And the name is nickel 2 oxide. Now, what I always do as a habit is I always double check the transition metal positive oxidation state to make sure there is in fact more than 1 positive oxidation state, and I should use a Roman numeral. And is the positive oxidation number that I came up with in fact accurate and actually on the element symbol box on the periodic table? Looking on the periodic table, nickel does have 2 positive oxidation states listed on the New York State periodic table, +2 and +3. I determined that nickel is +2, so I should use a +2 in the name. Now, this is a very similar looking formula, but I have a subscript of 2 on the nickel and a subscript of 3 on the oxygen. So here I know that I have nickel plus something again. I have oxygen -2, and if we look at it, there are 3 oxygen -2s, and there are 2 nickel plus somethings. So you have to use some reasoning. And again, it may be helpful to draw this out as the picture method. I know there's 2 nickel plus something. I have to determine the number there. And I have 3 oxygen minus 2s. That's going to give me a total negative charge of -6. To think, I need 2 positive numbers that, when added to a -6, will equal 0. Thus, each nickel ion has to be +3. The name here is nickel Roman numeral 3 oxide. And I think if you look at this slide overall, we can see how there's very similar formulas. FeCl2, iron Roman numeral 2 chloride. FeCl3, iron Roman numeral 3 chloride. We cannot clearly call both of these compounds iron chloride. Why? Because they have different formulas. Therefore, they need to have different names. And it's the Roman numeral that is the key element to making these two formulas different and distinguished from each other. Same thing with these two formulas. NiO versus Ni sub 2, O sub 3. They cannot both be called nickel oxide. The aspect that distinguishes them is the different oxidation state of the nickel ion in each of these formulas. Therefore, the names have to be different. Nickel Roman numeral 2 oxide versus nickel Roman numeral 3 oxide. Let's name compounds containing polyatomic ions. As we stated previously, you must know your polyatomic ions listed on table E well enough to recognize them in a formula. If you're given the formula name and it doesn't end in "ide," look for the polyatomic ion in the formula. There are exceptions. The polyatomic ion hydroxide and the polyatomic ion cyanide. The suffix "ide" in both of these polyatomic ions may lead you to think that these polyatomic ions are in binary compounds, but they're not. These are both negative ions. Hydroxide is OH minus and cyanide is CN minus, -1. There has to be one positive ion associated with each of these ions to make a neutral compound. If, for example, we had sodium hydroxide, we had a sodium +1 ion with a hydroxide ion, the resulting formula would be NaOH. That's 3 different elements. Therefore, NaOH is not a binary ionic compound. Same thing with cyanide. Let's say cyanide formed a bond with, let's take sodium again, Na+1 with Cn. Resulting neutral ionic compound would be NaCN. 3 different elements, not a binary compound, but the name would be sodium cyanide. Still ending in "ide," but not a binary compound. Let's look at these 2 examples here. We always need to be careful and double check the oxidation state of the polyatomic ion on table E. If I look at this formula, I recognize the presence of the NO3 nitrate polyatomic ion, sodium +1 ion and a nitrate ion. Note how I separate my ions with a plus sign. This is an important habit for the chemical equations unit coming up. The plus sign means "and." These are 2 distinct and separate ions. So the name of this is sodium nitrate. Now for this next example, I'm thinking picture method in my mind. I have aluminums, and you know aluminum is +3. I look at the formula, I have 2 of them. That's going to add up to a +6 charge. Sulfate, SO4 -2 on table E. There's 3 of them. That adds up to a -6. So in this ratio of 2 to 3, I have a neutral ionic compound. And the name is aluminum sulfate. Let's do some practice with ionic compounds containing polyatomic ions. I'm going to do the first one as an example. Li2CO3. The positive ion would be lithium, and there's 2 of them. So I'm going to write that here under coefficients since I have a designated column for that. Now be careful that you didn't do this. Li+1, and you see the subscript there, and you just put it here. You know your 7 diatomic molecules. This is not a diatomic molecule, so do not fall into that pattern and make that mistake. The negative ion is a carbonate polyatomic ion. Table E says that the polyatomic ion is CO3 -2. Again, you have to recognize your polyatomic ions, even when they're not in parentheses. This carbonate polyatomic ion is not in parentheses because there's only 1 of them. That's what I mean by coefficient. I want you to look at this formula and see that there's only 1 CO3 -2 polyatomic ion. It's not correct to put a parentheses around the carbonate, like so. I admit that if the formula was written like this, it would be easier for you to identify that, oh yes, this is a polyatomic ion, since there's only 1 of them. And the ratio of lithium +1 ions to carbonate negative ions is 2 to 1. The parentheses are not written in the formula. That is not correct. The name of this compound is lithium carbonate. And again, check the spelling and spell correctly using table E. Let's look at this next example. So at this point, I'd like you to stop the video and try the next 3 and come back and check your work. Welcome back. Let's check your work. The positive ion here is barium. Barium is a group 2 metal, has a +2 oxidation state, and the formula tells me I have 3 barium +2 ions. So I'm going to put a coefficient here of 3. Now you recognize that PO4 is the phosphate polyatomic ion. You look up the ion charge on table E, it's -3. How many are there of the phosphate ions present in this neutral compound? There's 2 of them. Now you may ask yourself if you need to use a Roman numeral, and the answer to that is no, because barium is not a transition metal, and barium only has 1 positive oxidation state. Therefore, the name of this compound is barium phosphate, not barium Roman numeral 2 phosphate. Let's look at the next example. PbOH parentheses 2. So I have a lead positive. I don't know the oxidation state yet, but I know there's 1 of these lead plus somethings in this compound. I see the polyatomic ion hydroxide. I know there's 2 of them. I think about the picture method in my mind. I have 2 of these hydroxide ions for an overall -2 charge. I have 1 lead plus something ion. Therefore, mathematically, lead must be +2. Now, is lead a transition metal? Yes. Does it have more than 1 positive oxidation state? Yes. Therefore, the name is lead Roman numeral 2 phosphate. Let's look at this last example. We have a calcium. You know by now this is +2. There's 1 of these ions present in this formula. C2H3O2. This is the acetate polyatomic ion. Each of them have a -1 charge. There are 2 of them. The name of this compound is calcium acetate. Again, no Roman numeral used on the calcium because calcium only has 1 positive oxidation state. What did we learn in this tutorial? We named binary ionic compounds. We looked at naming binary ionic compounds with transition metals. We did some practice involving compounds with transition metals. We named ionic compounds with polyatomic ions, and we did some practice naming compounds with polyatomic ions. Need more help? Please contact me. Have a great day.